In this video, we're going to have a look at resolving forces and looking at how to deal with forces in equilibrium. So let's break this question down. It tells you there's a particle P which is attached to the wall by a light and extensible string. So the term light means that there's no friction acting on the string. And whenever there's a string or tow bar or rope connecting two objects, in this case to the wall and this particle P, there's always tension acting up the rope. A horizontal force of 20 newtons is applied to P, as we can see on the diagram. The particle is in equilibrium. Now that's very important. That means that resultant force is equal to 0 horizontally and resultant force is equal to 0 vertically. Now on the more difficult questions, you'd also have to resolve moments. You can say clockwise equals anti-clockwise moments. But because there's not multiple forces at multiple distances, it's only just forces acting on this one particle, we don't really consider the moments in this question. Okay, the string taut. Taut just means that it's being held in that position, angle of 25 degrees. It says find the tension in the string. Well, we're going to use these two equations here. But before we do, let's think of all the forces that are actually acting on particle P. Now, a particle will always have weight acting vertically downwards. Before we deal with that though, if we have a look at this tension, we can split it up into horizontal and vertical components because that's where the resultant force is 0. So the component that is touching the angle or adjacent to the angle is always t cos 25. And the component that is not touching the angle, which is this horizontal component in this case, is t sine 25. So what we can say here, straight off the bat, is that, well, because horizontally resultant force is 0, we can say that t sine 25 is equal to 20. Now we can solve for tension, but I want to show you guys how you should approach this in an exam, because it's not always as easy as this. What I'd recommend is you draw all the horizontal and vertical forces on one diagram. So acting to the left is t sine 25. Acting vertically upwards is t cos 25, as we've just shown. T cos 25. And acting vertically downwards is always weight. Now that we formed this, we can sort of do this whole process a lot more streamlined. Like we said before, horizontal forces are balanced, so t sine 25 is 20. And rearranging this, we get that t is equal to 47.3 newtons. Once we've got that tension, we can use it now to find weight, because we also know that vertically resultant force is 0. So you can say that the weight is equal to t cos 25. In this case, that's 47.3 multiplied by cos 25, which is just equal to 42.9. And that's it. That's the final answer to your question. Be sure to leave a like if this video did help and subscribe. I'd appreciate it a lot. Feel free to share as well. I'm going to make a lot more on content resolving moments as well very soon. So keep a lookout for that.